I'm Marcel. I write the blog A Lesson on Gems, and today I'm going to talk about mathematics in literature. I'm going to use 3 different books to highlight how an understanding of mathematics and how authors use mathematics can heighten our enjoyment and understanding of literature. I'm going to do this in 3 ways. I'm going to talk about Flatland and show how using of mathematic symbols can be used in a way of satirizing something else. I'm going to talk about Alice in Wonderland and show how literature can actually be a critique of mathematics. And I'm going to talk about Shakespeare and Man Ray, where you use mathematics to organize your language. Flatland was written by Edwin Abbott Abbott and published in 1884. The main character in Flatland is square, like just a square, and he comes from the world Flatland, which is a 2-dimensional country, and it's written in a very similar style of Gulliver's Travels, in the sense that he is talking to us as like a travel documentary, in a sense. And in that time, very often the books that are written in the style of someone talking about a different country, traveling out and talk about a different country, it's almost always a satire of the country which the author is from, in this case England. You can see that in the most of books written in that style that way. Now, what separates Flatland from many of the other types of stories written in this genre is that while books like Gulliver's Travels is someone from our world traveling to somewhere else, in Flatland you have someone from the other world coming here and explaining about his world. And it has a very cute aspect, in the sense that he keeps saying, well, this isn't really about my world, but let's talk about my world. And it's very easy to see the way this is a satire about society, where he talks about how the more angles you have, the higher you go up in the rank. It's about how people with where the sides of the shape you have are equal have more worth than if they aren't equal. And this is a very clear parallel to the class system. And what was also very interesting, because it talks about how, for example, you have 3 ways of understanding what shape you're talking about. Because, of course, being in Flatland, you're not seeing the shapes as we see them like this, like flat like this. You're just seeing a line, because, of course, you're working in these 2 dimensions. So he says, well, how do we then recognize who is in the upper classes and who are in the lower classes? And he talks about 3 different ways. One is speech patterns, which is very clearly dialects. But he says this isn't very reliable because people can cheat when it comes to dialects. Then he talks about how you have feeling, in the sense that you can measure an angle. And as you know, the more angles you have in a shape, the wider those angles become. So you can sort of just touch one angle and then you can sort of know, oh, this is a square, or this is a triangle, or this is a hexagon. Which is, again, starts showing how Abbott is using mathematics to show how you can sort of recognize these different things. And that is quite similar to mannerisms in the real world, in the sense that one class had a certain set of way of acting, while a different class had a different set of acting. And the way you acted towards one another was a way of distinguishing yourself, saying that, oh, I'm in this class or I'm in this class. But he also goes one step further and really emphasizing and using mathematics to highlight the race issue. And he talks about the third, which is the way of sight. And what he talks about, he says that in this country we have a lot of fog. And of course, when you have a lot of fog, the fog that is further away, there will be more fog, and therefore it will be darker than what's closer to us. So, for example, if you have a triangle like this, where all sides are equal, in theory, I'm not very good at drawing, and you're looking at it like that, and you're just seeing a straight line, you can then distinguish by seeing that, oh, the fog here is much lighter than the fogs here. Ergo, I can mathematically calculate that this is this kind of triangle. Well, if you meet this kind of triangle, which is lower status, because these shapes will be much closer together, these two sides will much closer together, and these, of course, will be much more darker. You can say, oh, because the sides that are darker are closer together, I know that the sides aren't that further apart, therefore I can calculate that you're on a less status than this status. And of course, being higher up, the angles will then show up and you will become lighter, or the fog becomes lighter. Which, when I read it, was a clear way of talking about race, not just talking about how we very often think of race in the simplistic discriminative way, is that, okay, you're black, you're brown, you're white, but also the more complex way of whitewashing, in the sense that it's not just about being black, but that the whiter you are as a black person, the more status you have, which is another side of whitewashing. And that's something that he illustrates by using mathematics, with saying that the whiter you are, the higher status you have. But the interesting aspect that it is very known that it is a satire on Victorian England society with discrimination and everything like that. But another aspect that it also comes into contact to has with aspects within mathematics. Now, Abbott was a theologian, but he was also a mathematician. And what was happening in England and Europe at that time regarding mathematics was the not necessarily invention, but the growth of what's called non-Euclid mathematics. Now, Euclid mathematics was something that was from ancient time and is mathematical geometry, which has certain sets of axioms or rules that are given and that you just assume. Now, most of you, if you have gone to a Western education, will have learned that all angles in a triangle equals 180 degrees. Now, the rules of that is an example of Euclid mathematics. The same thing you see with 1 + 1 = 2. It's Euclid mathematics. We just assume that that is true, and then we base everything else on it. And what was happening in the 1800s was you had a bunch of mathematicians who said, well, how do we know it's true? And the people who liked Euclid mathematics would say, well, because we've based everything on that these things are true, like our houses, and they're not fallen down yet. And then the other will go, yeah, but how do you know? Because nothing has exploded or imploded or gone wrong. Everything is like it should be based on this mathematics. The rules are proven by all the years it has actually worked, the thousands and thousands of years it actually worked. Yeah, but how do you know that this is true? Oh, fine, just do the math. So you had this very discussion about this, and the interesting side that this wasn't just a practical discussion where people were sort of saying, well, how do we use mathematics? But Euclid Mathematics was saying to people, and was a part of this ideology that people have, that you had a fixed truth, that everything was predictable, because that's what Euclid said. 1 + 1 = 2 every time. All the angles of a triangle will equal 180 degrees every time. And this gave an idea of this universal truth that didn't just influence the mathematics, but influenced most sides of the society. And then what non-Euclid mathematicians then did wasn't just questioning mathematics, they were questioning the idea of a universal truth. And some has then taken it to question the existence of God, taken it into question the existence of a higher plane. But what's interesting about Edwin Abbott Abbott is that he wasn't just a mathematician, as I said, he was also a theologist. And he wrote theologist papers. And that's also something that you see in this book. Now, after Square talks about Flatland and introduces us to Flatland, which is the 2 dimensions, he also visits Pointland, which is no dimension. He visits Lineland, which is 1 dimension. And he also visits Spaceland, which is the 3 dimensions, our land. And he references the readers, which is us, as people inhabiting Spaceland. And therefore what's interesting is that he's talking about the dimensions that aren't in our understanding here and now, but is sort of on the next level. And that's also something that came with the discussion of Euclid Mathematics. It was, or non-Euclid Mathematics, it was the discussion with whether or not there exists a 4th dimension, a 5th dimension, a 6th dimension. And what Abbott does is pretty much then questioning, is there a 4th dimension? Is there a 5th dimension? And what exists in this 4th and 5th dimension? So he places himself in the school who says that because of non-Euclid mathematics, because there is an impossible of an existence of a higher plane, there is also a possibility of an existence of God. And therefore you can sort of see that understanding that mathematics in this sense isn't just about rules and pluses and minuses, but also about how we understand the world we live in. We understand that there is a second sort of dimension to this book, and a second thing that he is actually questioning, and well, he is answering, but is questioning in the sense in this book, which is this it? Is the world we are now living in and the rules we are now living in it? Or is there something else? Is there something more that we could never question when we were limited by Euclid mathematics? And that sort of shows how complex a book like this actually can be, and how philosophical you can actually be with regard to mathematics. So follow me next time when we'll continue in this 3-parters of mathematics and literature. We'll talk about Alice in Wonderland and how that might be another entry in the discussion between Euclid and non-Euclid mathematics. And remember, it's better to be a witty fool than a foolish wit.